Hi guys, today we're going to be covering lesson 32-5, complex solutions. Learning targets. Use the imaginary unit I to write complex numbers. Solve a quadratic equation that has complex solutions. When solving quadratic equations, there's always one, two, or no real solutions. Graphically, the number of x-intercepts is helpful in determining the number of real solutions. When there is one real solution, the graph of the related quadratic function touches the x-axis once, and the vertex of the parabola is on the x-axis. When there are two real solutions, the graph crosses the x-axis twice. When there are no real solutions, the graph never crosses the x-axis. Item 1. Graph the function y equals x squared minus 6x plus 13. Use the graph to determine the number of real solutions to the equation x squared minus 6x plus 13 equals 0. Now in my book here, the graph is already there, but let's talk about how we got this graph. Recall from a couple lessons ago that from the equation we can find the axis of symmetry. In the axis of symmetry, that formula is x equals, because remember the axis of symmetry formula is a vertical line, which is always x equals some value. So it's negative b over 2a. And so we just go ahead and fill this in. First of all, we want to know the information. We have a is equal to 1, b is equal to negative 6, and c is equal to 13. So we'll go ahead and fill this in. It's going to be negative, and then it's negative 6 over 2 times a, so it's 2 times 1. So what we're going to end up with is x is equal to, now I have a negative and a negative. I have 2 negatives in this whole thing, so it's going to be a positive. And 6 over 2, so 6 divided by 2 is 3. So my x value is going to be 3. So to find out what my y value is of my vertex, it's going to be x something, xy. Obviously, and so we're going to go ahead and we know that it's 3. And to find our y value, remember the quadratic formula is, or the quadratic equation is that right there, the y equals x squared minus 6x plus 13. So to find y, we simply plug in the x's. So it's going to be 3 squared minus 6 times 3 plus 13. So 3 squared is 9. 6 times 3 is 18. And plus 13. And so we have 9 minus 18 plus 13. So we just go from left to right. 9 minus 18 is negative 9 plus 13. And so y is going to be equal to 4. So my vertex is going to be the point 3, 4. So I look and I say, well, okay, I can go over 3, up 4, and it's going to be that point right there. Now that still doesn't complete the graph. I've got to go ahead and figure out some more things. So I've got to plug in a few numbers here and there on this, or I could put this whole thing in vertex form. I'm just going to plug in a number. So I'm going to plug in a 0, because 0 is the easiest one. So if I plug in the number 0 for x, the y is going to be 13. I do that on purpose, because now that tells me my y-intercept is 13, and that's right there. And I know that if this is my axis of symmetry, if I'm going over from 3 over to 0 and getting that there, I'm going to do the same thing here. And now I can go ahead and draw my graph. Now what I'm looking at when I see this graph is I say, well, my vertex is above the x-axis and I'm a happy flower, I'm going upward. So therefore, how many x-intercepts are there? Well, we would say there are no real solutions. All right, so let's go ahead then and move on. Item 2, construct viable arguments. What does the number of real solutions to the equation in item 1 indicate about the value of the discriminant of the equation? Explain. The value of the discriminant is less than 0 or negative. When the value of the discriminant is less than 0, there are no real solutions. This is different from stating there are no solutions. In cases where the discriminant is negative, there are 2 solutions that are not real numbers. Imaginary numbers offers a way to determine these non-real solutions. The imaginary unit, I, equals the square root of negative 1. Imaginary numbers are used to represent square roots of negative numbers, such as the square root of negative 4. Example A, square root of negative 4. To find out what the square root of negative 4 is, we go ahead and do like we would normally do. Normally we would, when we have a square root, we would separate out the factors, so we look for a perfect square factor. So in this case, the perfect square factor is going to be 4. In order to get negative 4, I got to multiply that times a negative 1. So negative 1 times positive 4 is negative 4. Okay. Well, the square root of negative 4 is 2. And we know now that the value that we're going to write for the square root of negative 1 is I. So the answer here is 2i. So let's go ahead and do some of the try these. All right, try these A. We're going to simplify the square root of negative 16. Square root of negative 16 is the same as the square root of 16 times the square root of negative 1. The square root of 16 is 4, and we know that the square root of negative 1 can be represented by the value I. So the answer is 4i. So don't get confused about where the negative sign is. In this case, we have the negative the square root of negative 9. So what we're going to do here is we're going to say, well, that's just negative or negative 1 out here times the square root of 9 times the square root of negative 1. Because 9 times the square root of 9 times the square root of negative 1 is the square root of negative 9. And then, of course, the negative sign is really an implied negative 1. So let's go ahead and do the work. The square root of negative 9 is 3. That's I. And then the negative 1 just makes the whole thing negative. The answer is negative 3i. The last one is the square root of negative 8. Could be rewritten as the square root of 8 times the square root of negative 1. Square root of 8 can be simplified further. That is the square root of 4 times the square root of 2. And don't forget the square root of negative 1. And the square root of 4 is 2. Square root of 2 is irrational, so we leave it that way. And then the square root of negative 1 is I. So it's 2 times the square root of 2 times I. The order of this also, another way of writing this is 2 times I times the square root of 2. And that way we know it's not in the radical either. Problem solving and problems involving imaginary numbers can also result in complex numbers. A complex number is a plus b times I. where a and b are real numbers. In this form, a is the real part and b is the imaginary part. And so when we solve these using the imaginary number, we can create this complex answer, a plus bi. So we're going to go ahead and do example B. Example B, we're going to say, well, that's x squared minus 6x plus 12 equals 0. We'll start off by saying, well, what's a, b, and c? So a is equal to 1, b is equal to negative 6, and c is equal to 12. And we'll go ahead and use the quadratic formula. In this case, x is equal to negative b plus or minus the square root of b squared minus 4ac, all that over 2 times a. And we'll plug in the numbers. X is equal to negative 6 plus or minus the square root of, that's going to be the negative 6 squared minus 4 times 1 times 12. All right, so the opposite of negative 6, or negative from negative 6, is positive 6, plus or minus, well, I guess this is all that over 2 times 1. And that's going to be the square root of 36 minus, and again, it's a minus because we have a only one negative sign. That's 48. All that over 2. X is equal to 6 plus or minus the square root of 38 minus 36 minus 48, which is 12. Square root of negative 12. All that over 2. Let's simplify the square root of negative 12. The square root of negative 12 simplifies to the square root of 12 times the square root of negative 1. And then the square root of 12 can be further simplified to the square root of 4 times the square root of 3 times square root of negative 1. So it's going to be 2 times I times the square root of 3. So it's going to be x is equal to 6 plus or minus 2 times I times the square root of 3. All that over 2. Now we can simplify. 6 over 2 is equal to 3. Plus or minus 2 over 2 cancels out, so it's just going to be I times the square root of 3. And that's going to be our answer. Now remember, what that means is x plus I. Let's try that again. X equals 3 plus I times the square root of 3. And x is equal to 3 minus I times the square root of 3. Keep in mind the first part is the real part, the second part is the imaginary part. All right, try these B. So solve each equation. So this one here, we can use the square root method. We're going to look at this and we're going to say, well, that's going to be x squared plus 100 equals 0. So I'm going to get the x squared by itself. So it'll be x squared, subtract 100 from both sides, and it's equal to negative 100. So if we do the square root method, we're going to get the square root of x times the square root of negative 100. So the square root of x squared is x. The square root of negative 100 is going to be, well, that's going to be the square root of 100 times the square root of negative 1, which could be written, square root of 100 is 10. And then the square root of negative 1 is written as the imaginary number I. So the answer here is x equals plus or minus 10 times the square root of I, or 10 times I. All right, So b is x squared minus 4x equals to negative 11. I can solve this using the quadratic formula. So that's going to be x squared minus 4x plus 11 equals 0. Again, I don't have factors of 11. When we add them together to get negative 4. So we'll use the quadratic equation. That's going to be a, b, c. And so it's going to be 1, negative 4, 11. And we'll plug that into the quadratic formula. X is equal to negative b plus or minus square root of b squared minus 4ac, all that over 2a. Plug them in. So it's negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 11. All that over 2a. So x is equal to 4 minus a negative 4 plus or minus the square root of, let's go ahead and figure out the discriminant. So that's going to be 16 minus 4 times 1 times 11, which is 44. So 16 minus 44. So we, of course, write this in the usual way, 44 minus 16, and that's going to be 28, but the larger number is negative, so it's negative 28. So our discriminant is negative 28, all that over 2. And so x is equal to 4 plus or minus the negative 28 could be rewritten as 28 could be rewritten as the square root of 4 times the square root of 7 times the square root of negative 1. So the square root of 4 is 2, square root of 7, square root of 1 is I, all that over 2. And then we're going to simplify. X is equal to 4 over 2, which is 2, plus or minus 2 over 2 cancels out, so it's just I times the square root of 7. So it's 2 plus or minus I times the square root of 7. Check your understanding. Simplify the square root of 27. So the square root of 27 can be simplified by checking to see what the factors are. So we have square root of negative 27 can be written as, that would be 9 times 3. So the square root of 9 times the square root of 3 times the square root of negative 1 to get rid of the negative. And so that's going to be I. Oh, I don't know why I put a T on there. So that's going to be I. And so we're going to have 3 times I times the square root of 3. 3, which was the square root of 9. I, which was the square root of negative 1. And then the square root of 3 is the irrational part. All right, so let's go ahead and do item number 4. Check your understanding. We're going to solve x squared plus 4x plus 6. So we could think of different ways that we can do this. We can try factoring. And in that case, I would be looking for factors of 6 that when you add them together, you get 4. So the factors of 6 are 1 and 6, that adds to 7. 2 and 3, that adds to 5. So it cannot be factored. So we're going to go ahead and use the quadratic formula. So it's going to be A, B, C. A, B, and C. So A is 1, B is 4, C is 6. And we'll go ahead and plug it in. It's going to be x is equal to negative b plus or minus square root of b squared minus 4ac, all that over 2a. And we'll plug it in now. So it's negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 6, all that over 2 times 1. So I'm going to start working out. -4 plus or minus, let's do the discriminant. Discriminant is going to be 16 minus 4 times 6 is 24. So 16 minus 24 is -8 over 2. And the -8 could also be simplified. That's going to be 2 times the square root of 2. So we'll do that on this one. X is equal to -4 plus or minus. This could be rewritten as -1 times the square root of -1 times the square root of 4 times the square root of 2. The square root of -1 is going to be the I. The square root of 4 is going to be 2. And then it's going to leave us with the square root of 2. All that over 2. Then we simplify. X is equal to -2 plus or minus 2 over 2 cancels. I times the square root of 2. And that should be the answer right there. Okay, so we're going to go ahead and leave the practice problems for you to do as homework. Remember, if you have any questions, come to tutoring weekdays at 3 o'clock via Zoom. The link is on the class board.